get metal into the tablet. So you just have to concentrate on the open part where you fill, where it goes into the pre-compression. That's where you get your metal into it. I need to hurry up a little bit here. Okay, here's an example about the penetration depth. That just will show you where inside of the die you're going to make the tablet. I skipped a few pages. Sorry about that. It's moving up and down. So what happens if you compress the tablets too high inside of that die? What do you think? I'm losing a lot of powder. Because if I try to compress that, instead of getting the air out of the die, I'm going to get the air and the powder out of the die. If I go too deep in the die, what kind of effect will that have? It's going to be hard to eject the tablets. Because the lower I go in the die to make the tablet, as hard it is to push it out. If I have to push it out throughout the entire die, it's a lot of force. Yeah. Air won't go out. Dwell time. What's the definition of dwell time? Right there. Dwell time is defined as constant pressure. So if you look at a tooling head, the punch head, you got a flat area on top. So dwell time is defined of when the compression roll goes across the flat area and applies constant pressure to make the tablet. That's your dwell time. There's a better picture. Now looking at this picture, anybody sees anything wrong with that? You can't speak. You've been to the other class. Is there anything wrong on that picture? You got different diameters on the head flat, right? That was actually a call you had, Mike, right, where they said, I got a problem with my hardness. And Mike just looked at the box with the tooling and said, I know where your problem is, not even seeing the machine. Look at the diameter of the head flat over this one here and the one next to it. Huge difference. So that's going to make a hard tablet. This is going to make a soft tablet. There's different designs on the head. One is a head, a regular TSM, and there's a domed head which is rounded a little bit. And they actually mixed the different styles of heads together, and that gave them the condition that they couldn't maintain the hardness. Coming to your question about why do you need the vacuum on the machine. If you go to the pre-compression and you actually enter into the die, what's happening is that you have powder coming out and air coming out. If you don't have any point of vacuum at that particular area, you will have a lot of dust build up inside the machine. So a lot of machines like the Fettis you have, they have a shroud going all the way around. Really not needed all the way around. The only place it is needed is where the punch goes into the die at the pre-compression and starts making a tablet. That's where you lose powder. So if you have a concentrated port just looking at that area and sucking the powder off, will be the same result. Anywhere around, there should be no powder anymore because you're making tablets. I want to go quickly over some other functions you have in here. Most of the high-speed presses have something where you control your average compression force. While the machine is running, it's going to look at individual forces on your punches and is building an average. And that becomes a control factor for the machine. This is important that you have some kind of a limit set to it. If you run out of powder, you want to stop the machine before you run the machine empty and you have a possibility that the punches are getting together. So the average you're getting low and the machine's running out of